Hi everyone, it's Mrs. Bebo. In this video, we're going to continue talking about solving two-step equations, this time with rational numbers. So let's take a look at our examples here. So the first question says solve 5x minus 3 and 8/10 equals negative 6 and 4/10. So even though we have rational numbers involved, the steps are going to be the same as when we solved our equations that had integers. We're going to start with getting rid of this constant term first. So how do I undo subtraction? We add. So we're going to add 3 and 8/10 to both sides of our equation because, again, remember, we want to keep each side of our equation balanced. So if we do one operation to one side of our equation, we have to make sure we do that same operation to the other. Now, this is going to cancel out on the left-hand side, which is great. That's exactly what we want. And we'll be left with 5x equals, and then negative 6.4 plus 3.8 is going to be negative 2.6. Last step to solve this, we're going to divide both sides by 5. And then we are going to end up having to do a little bit of division here. So this 2 and 6/10 divided by 5. We're going to say 5 goes into 26. This would be 5 times. And then we can add a 0 and bring that down. That's going to be twice, bring up our decimal point, and so we get an answer of 52/100. However, this was a negative divided by a positive, which means this is going to be a negative 52/100. All right, so let's take a look at our second example. So solve negative 5 and 7/10 equals negative 6x minus 8 and 1/10. Our variable is now on the right-hand side, so that's something to make note of. And at this point, again, we're just going to take care of this constant. So just focus on one step at a time. Get rid of the constant first that is on the same side as your variable term. So how do I undo subtraction? Again, we have to add. So we're going to add 8 and 1/10 to both sides of our equation. Again, same thing on both sides. This negative 5 and 7/10 plus 8 and 1/10 is going to put us into the positives because we're adding more that is positive. And so we're going to end up with 2.4 equals this negative 6x. And then we just have one final step, which is to divide both sides by negative 6. And then writing out this division just so we can see what's happening here, we got 2 and 4/10 divided by 6. I'm just going to ignore the negative for now. 6 goes into 24 4 times, and bringing up our decimal point, this would be 4/10. Now, going back and focusing back on that negative sign, that is going to end up being a negative answer in this case. So it'll be negative 4/10 equals x. And then that's our final answer. All right, moving on. So we got solve 4 plus 1/5 r equals negative 1. So the variable is back on the left-hand side. Again, we want to take care of this constant term first. So how do I undo this positive 4? How do I make it go away? We're going to do that by subtracting it. So we're going to subtract 4. We need to make sure we do the same thing to the right-hand side. So this 4 minus 4, that's going to cancel out. So we'll be left with just this 1/5 r equals, and then negative 1 minus 4 is going to put us at negative 5. Now, to get rid of this fraction, we are going to multiply both sides by the reciprocal of it. So that was talked about in the solving one-step equations video, so make sure you check that out for more, detailed information on how it works. But essentially, to get rid of that fraction, we're going to multiply by its reciprocal. So those are going to cancel out, and then we will be left with r equals, and then this is essentially just multiplying by 5. So negative 5 times 5 is going to be negative 25. And then that's it for that one. And then our last example on this slide, we got negative 2 plus 2/3 w equals 10. So again, we're going to take care of that constant term that's next to our variable term over there on the left-hand side. To do that, we'll start off by adding 2, because this is a negative 2. So if I want that to turn into a 0, right, if I want this to cancel out, negative 2 plus 2 is going to be 0. So that's why we do that. Then we have 2/3 w equals 12. To get rid of this fraction that's being multiplied to w, we're going to multiply by the reciprocal. So we're going to multiply by 3/2 on both sides of our equation here. So 3/2 times 2/3, that makes 1 whole, so we're left with just w, 1 w technically, but we don't need to write the 1. And then this 12 over 1 times 3 over 2, we can actually cross cancel here between the 2 and the 12. 2 divided by 2 is 1. 12 divided by 2 is going to be 6. So we're going to be left with 6 over 1 times 3 over 1, or essentially just 6 times 3, and that's going to be 18. All right, we got a few more examples with rational numbers. So this one on the left says 3/5 x plus 22 equals 28. Again, if it helps, you can draw that line to just visually see the left-hand side from the right-hand side to make sure we're doing the same operation of both sides as we move through solving this equation. So we're going to take care of that constant first. To get rid of this 22, we're going to subtract it. So we'll subtract 22 from both sides. We'll be left with 3/5 x equals 28 minus 22 is going to be 6. And then again, to get rid of this fraction that's next to our variable here, so 3/5 times x, to get rid of it, we're going to multiply by the reciprocal of it. So we're going to multiply both sides by 5/3. I'm going to add a 1 underneath the 6 so I can see if there's any cross-canceling available, and if not, we just multiply across the numerators and multiply across the denominators. But we can actually cross-cancel in this case, so we'll cross-cancel between the 6 and the 3. So 3 divided by 3 is 1, 6 divided by 3 is 2. On the left-hand side, all of that canceled out, right? 5/3 times 3/5 is 1 whole, so you're left with 1x or just x. And then 2 times 5 is going to be 10. All right, so this middle question, -1/3 x plus 1 equals -7. To get rid of that constant, that 1, we are going to subtract it. So we're going to subtract the 1 from both sides. We'll have -1/3 x equals -7 minus 1 is going to put me at -8. When you have what is called a unit fraction, the reciprocal of that ends up being an integer, right? So this reciprocal of -1/3 is going to be -3/1, which is the same as just -3, right? So the nice thing again with those unit fractions is that the reciprocal just ends up being an integer and makes that multiplication super nice, because now on the left-hand side, again, as we know, that's going to cancel out. And over here, it's just -8 times -3, so +24. All right, so next one, the last one on this slide, we got -5 plus 3/10 x equals 7 and 9/10. Again, if it helps, you can draw that line through your equal sign. First step, to get rid of this -5 here, because again, that's my constant term, we are going to add 5, because -5 plus 5 is going to be 0. That's going to cancel out. So -5 plus 5, that cancels. Again, if it helps, you can always draw that 0 over it. I haven't been doing that on some of the questions. It kind of goes in and out on when I do it, but if it helps you to just visually see it, great, do it. And I am left with this 3/10 x because those canceled out. The 7 and 9/10 plus 5, that is going to be 12 and 9/10. Because again, if it helps, you can put 5.0 just to make sure that you are lining up that decimal point. And now we only have one more step to solve this. To get rid of that 3/10 in front of x, we're going to divide both sides by that 3/10, because the inverse of multiplication is division. And then with this question, it essentially just becomes, because we're going to end up having to move this decimal point over to the right when we do our long division, right? And we have to do the same thing on the inside one. So this essentially just becomes the problem, 129 divided by 3, which ends up being 43. So this ends up being x equals 43 for our answer there. All right, so for this video, we just have one more example, and it's going to be a story problem. So in this one, where we're dealing with chemistry, it says the table shows the freezing point of several solvents in degrees Fahrenheit or degrees Celsius. The formula F equals 1 8/10 C plus 32 can be used to convert between degrees Fahrenheit and degrees Celsius. What is the difference in degrees Celsius between acetone's freezing point and carbon disulfide's freezing point? So there's a lot going on in this question, but the one thing that we do want to highlight right away is this formula that, again, we didn't have to come up with. They gave it to us, so that's going to be a totally different section when we actually have to write the equation ourselves and then solve it. We're going to just use this in this situation to help us figure out, again, the difference in degrees Celsius. So that's going to be key too, because as I said in the table, some of them are in Fahrenheit and some of them are in degrees Celsius. So in order to find the difference, we need to convert one or both of acetones and carbon disulfide's given temperature into the correct unit. So if I look at my table, we're looking at acetone, which is in degrees Fahrenheit, which is what we don't want, right? We're going to end up having to convert this into something degrees Celsius. And then we're looking at the carbon disulfide, which is already good. That's in degrees Celsius. And then lauric acid and water are not important because we're not worrying about those two. All right, so all we have to do now, carbon disulfide again set. That's already in degrees Celsius. So we need to take acetone's freezing point, which is in degrees Fahrenheit. We're going to plug it into this formula here. So it's going to say Negative 138 and 6400ths equals 1 8/10 C plus 32. Okay, so all I did there was I took the given formula and plugged in what I knew, which is Fahrenheit. That's the only thing I know. And then we are going to be solving for C. So going back to what we've been doing on all these previous problems, we're going to start by taking care of this constant first. How do I get rid of that adding 32? How do I make that go away? We're going to subtract it. So we'll subtract 32 from both sides. I'm going to go ahead and just add my decimal points in there, just so that my decimal point and my decimal places in there, so that we can just make sure everything is nicely lined up. This is going to end up being negative 170 and 6400ths, and this equals 1 8/10 C. And then we just have one more step, right? And so hopefully at this point, you're starting to see it's very similar every single time. Add or subtract, and then multiply or divide as your second step. In this case, to get rid of this 1.8 that's being multiplied to C, we're going to divide. So we'll divide both sides by 1 8/10, divide by 1 8/10, and then this is where we're going to end up having to do some long division, right? So we'll set it up. We're going to have this 170.64 on the inside, and then this 1 8/10. Now we do have to end up moving our decimal points. So essentially what we're going to end up doing is 1,706 4/10 divided by 18. So going through this, we would figure out that 18 can go into 170. That's going to be 9 times, which is 162. We'll subtract, get 8, bring down the 6. 18 goes into 86 4 times, and that's going to be 72. So we subtract, we get 14, bring down the 4 here. Make sure we carry up that decimal point, and we find that 18 can go into 144 exactly 8 times. All right, so we get 94 8/10. Now, paying attention to our signs, we got a negative divided by a positive, so this is going to end up being a negative 94 8/10 degrees Celsius for our freezing point for acetone. So that's not our final step though, because we do have to answer the question, which is what is the difference between the freezing points between this acetone and carbon disulfide? So we're going to go through and find the difference now. So to find the difference, we'll take negative 94 8/10. We're going to subtract the negative 111 5/10 from it. And when we subtract here, this is actually going to turn into addition. So it's going to be negative 94 8/10 plus 111 5/10. And then the fun thing with math, right? We just change it to addition, but technically because these are different signs, we're actually going to subtract the two. So we'll do 111.5 minus 94.8 to find a difference of 16 7/10 degrees Celsius. And then that would be your final answer for this question. So hopefully that helps you with solving two-step equations that involve rational numbers. Thanks for watching.